Welcome to this video on probability and sampling. Students will design and use simulations to estimate probabilities of outcomes of chance experiments and understand the probability of an outcome. They generate samples from a given population and examine the distributions of the samples. Here are the essential vocabulary words that will be introduced in the unit: chance experiment, event, and a quartile range, mean, mean absolute deviation, median, outcome, population, probability, proportion, quartile, random, range, representative, sample, and sample space. Students will be working with probability. A probability is a number that represents how likely something is to happen. For example, think about flipping a coin. The probability that the coin lands somewhere is 1. That is certain. The probability that the coin lands heads up is 1/2, or 0.5. The probability that the coin turns into a bottle of ketchup is 0. That is impossible. Sometimes we can figure out an exact probability. For example, if we pick a random date, the chance that it's on a weekend is 2 out of 7 because 2 out of the 7 days fall on the weekend. Other times, we can estimate the probability based on what we have observed in the past. To find an exact probability, it is important to know what outcomes are possible. For example, to show all possible outcomes for flipping a coin and rolling a number cube, we can draw this tree diagram. The branches on this tree diagram represent the 12 possible outcomes for heads 1 to tails 6. To find the probability of getting heads on the coin and an even number on the number cube, we can see that there are 3 ways this could happen: heads 2, heads 4, and heads 6 of the 12 possible outcomes. That means the probability is 3 out of 12, or 0.25. A table can show the same result, and so does this ordered list. When we want to know more about a population but it is not feasible to collect data from everyone in the population, we often collect data from a sample. In the lessons that follow, students will learn more about how to pick a sample that can help answer questions about the entire population. Students will be working with data. Sometimes we want to know information about a group, but the group is too large for us to be able to ask everyone. It can be useful to collect data from a sample, which is sum of the group, of a population, which is a whole group. It is important for the sample to resemble the population. Here's a dot plot showing a population, the height of 49 plants in a sprout garden. For example, consider the distribution of the plant heights in centimeters for a population of plants shown in this dot plot. This sample is representative of the population because it includes only a part of the data, but it still resembles the population in shape, center, and spread. A representative sample of this population should have a larger peak on the left side and a smaller one on the right side, like this one. This sample is not representative of the population. It has too many plant heights in the middle and not enough really short or really tall ones. A sample that is selected at random is more likely to be a representative of the population than a sample that has been selected any other way.